In this video, we are going to look at two examples of using sum or difference formulas to find the exact value of trigonometric expressions. In our first example, we want to find the exact value of cosine of 105 degrees. Now there's a unit circle down here, and as we can see, 105 degrees does not show up on the unit circle. If it did, we could just read the x-coordinate of it off and have its exact value. But instead, we're going to have to use a sum or a difference formula. And so our first goal is to find two numbers that either add or subtract to 105. And we want those two numbers to be degree measures that show up on the unit circle, so we can use one of these two formulas, either a cosine sum formula or a cosine difference formula. There are several different combinations that can do this. We can use a sum of 45 degrees and 60 degrees. 45 plus 60 will add to 105. Or we could use the difference of 135 degrees minus 30 degrees. That also subtracts to 105 degrees. Or we could use the difference of 150 minus 45 degrees. That's a difference that also subtracts to 105 degrees. Either one of those combinations or any other combination that adds or subtracts to 105 degrees would work. If we chose to use the 45 plus 60 degree formula, that is a sum. And so if we chose to do that, then we would have to use the cosine sum formula. However, if we chose either of the other two that are differences, then we would need to use the cosine difference formula. All three would give the exact same answer though. In this example, I am going to use the sum. I'm going to write cosine of 105 degrees, which is what we want to find the exact value of, as cosine of 45 degrees plus 60 degrees. So my A is 45 degrees and my B is 60 degrees. According to the formula, cosine of A plus B is equal to cosine of A. So I'm using this formula here. So we would have cosine of 45 degrees multiplied with cosine of B, so multiplied with cosine of 60 degrees. And then we subtract sine of A, so sine of 45 degrees, multiplied with sine of B, so multiplied with sine of 60 degrees. And now all four of these values, cosine 40, cosine 60, sine 45, and sine 60, we can find the exact values of using the unit circle. So cosine of 45 degrees is equal to root 2 over 2. Cosine of 60 degrees is equal to 1/2. Sine of 45 degrees is equal to root 2 over 2. And sine of 60 degrees is equal to root 3 over 2. And then we will multiply these fractions and continue simplifying. Multiplying straight across the numerator, root 2 times 1 is root 2. 2 times 2 is 4. And we are subtracting. Root 2 times root 3 is root 6, and 2 times 2 is 4. We already have a common denominator, so I can write this as one fraction to get root 2 minus root 6, all divided by 4 as the final answer for cosine of 105 degrees. In our second example, we want to find the exact value of sine of pi over 12, and the initial goal is still the same. First, we need to find two radian measures on the unit circle that either add or subtract to pi over 12. We are not going to be able to find two radian measures that add to pi over 12, but it is possible to find two radian measures that subtract to pi over 12. In fact, 3 pi over 12 minus 2 pi over 12 is equal to 1 pi over 12. And notice that these two radian measures are on the unit circle because when we simplify these fractions, 3 pi over 12 simplifies to the fraction of pi over 4, And 2 pi over 12 simplifies to the fraction of pi over 6. And so both of those radian measures do show up on the unit circle. And so we will use a sign difference formula since we were able to write pi over 12 as the difference of two measures that show up on the unit circle. So we will be using the sign a minus b formula, where our a will be pi over 4 and our b will be pi over 6. So we are finding sine of pi over 12, which is equal to sine of pi over 4 minus pi over 6. So plugging into this formula, sine of a minus b is equal to sine of a, so that is sine of pi over 4, multiplied with cosine of b, so that is multiplied with cosine of pi over 6. And then we will subtract cosine of a, so cosine of pi over 4, multiplied with sine of b, so multiplied by sine of pi over 6. And remember that you don't have to memorize these sum and difference formulas. You will be given them on the exam. And so now we can find the exact value of these four different expressions from the unit circle. Sine of pi over 4 is root 2 over 2. Cosine of pi over 6 is root 3 over 2. Cosine of pi over 4 is root 2 over 2. And sine of pi over 6 is 1/2. And so now multiplying these fractions, root 2 times root 3 is root 6. We just multiply the numbers under the radicals. 2 times 2 is 4. And then we are subtracting. Root 2 times 1 is root 2. And 2 times 2 is 4. We already have a common denominator, so we can write this as 1 fraction of root 6 minus root 2, all divided by 4. And that is our final answer for sine of pi over 12.